Hello everyone. This is the video lecture for Calculus 2, section 10.5, conics. We've done conics back in pre-calculus, so there's nothing new here. And in fact, because all my videos are being posted on YouTube now, you can actually go back to the pre-calculus videos and review this stuff in much more depth. But I'm going to just do a quick overview, and I am going to treat it as if you might have seen some of this, but I'm going to also treat it as if you haven't seen the style that I've done it, because I do it a little differently than some other people. So let's just jump in and I'll give you formulas along the way. 10, 5, 0, 0, 4. I have 9x squared plus 8y is equal to 0. And they say find the shape, graph it, vertex, center, focus, directrix, and all those good things like that. Well, this is a parabola. This is a parabola, and how do I know this in particular? Is because I have one component that is squared, and that is it. The formula for parabola, at least in this particular case, is x minus h all squared is equal to 4 times p times y minus k. H and k are your center vertex. Here I actually named them the same thing. A lot of folks say, oh, it's the vertex because we're talking like the vertex of the parabola. But I also call it the center because we use h and k as the center for all the other ones anyways. And it kind of makes sense. This is like the center of your parabola. And so my hk is where the center is. My p is my focus distance. Focus distance. And that's a focus is going to be somewhere around right here for a parabola. So that distance here, that's your p distance right there, that distance there. And I can decipher all of that just by looking at this somehow. So I need this to look like this. And what I'm going to do first off is I'm going to move over the y to the other side. And so I got a negative 8y. Notice that I'm kind of setting it up now. I'm going to divide by the 9 on both sides. And so what I have is x squared is equal to negative 8/9 y. Now, this is supposed to look like that, and it does. Let me rewrite it a little bit differently. Let's say x minus 0 squared is equal to negative 8/9 y minus 0. So I'm adding some zeros to show that I do have this format. What I don't yet know is what my p is. So right here, this chunk is supposed to be equal to 4p. And so I'm going to go on the side and say negative 8/9 is equal to 4p, and I solve for p. Well, I divide by the 4, obviously, and I get negative 2/9 in the end. Things cancel with the 8 and all that stuff. And so this is your focus distance right here. So this is important. We're going to use it here in just a second. And now I need to put it all together. And so let's graph it first. Notice that my center's at 0, 0 because they didn't have any pluses or minuses there. So definitely 0, 0 for my vertex center. Because it's a negative p means my focus is going to be down here. So focus is down here. That distance is a negative 2/9. So I guess you can actually say it's right here at negative 2/9, like a y value. And it's going to be going like this here. The focus is always on the inside of the parabola. And so it's an upside down parabola centered at 0, 0. And I guess you can also find the directrix is right here. Now the directrix is always the same distance as to the focus. So if this was 2/9 distance, then this is a 2/9 distance. Notice that this was a negative, so this is technically a positive. They're always going in the opposite directions. If somebody's asking, hey, what's my directrix? Well, now you know it's going to be this 2/9 stuff. And so let's go ahead and answer what they have. They say, hey, find the vertex center. Again, they'll probably just have vertex. I'm going to say either one. And we have to fill it in. Well, it's 0, 0. We already found that. Find the focus. And they want it as a point. So what is this point right here? Notice that my x value is 0, but my y value is a negative 2/9. That's easy. And then it says find the directrix. Now the directrix is not a point, it's an equation, so it just kind of has a box like that. If you notice, it's a horizontal line. Horizontal lines are y equals, and it's at a height of Well, 2/9. And so it's going to be equal to positive 2/9. You don't have to put the positive sign in. I'm just emphasizing. That is the entirety of that question. Now, let's actually do some hard ones. So 10, 5, 0, 0, 7. I have y squared plus 6y plus 2x plus 5 is equal to 0. And they want the same thing as last time. Graph it, vertex, center, focus, directrix, that kind of stuff. Well, this is definitely still a parabola because we only have one term that's squared, and that means it's a parabola. But it's all mixed up and weird, so what do we even do? I'm going to first start off by moving this over here because my format, I guess I got to show you what the formula should look like. Notice it is the same formula, but I'm just moving my my x's and my y's around basically. So this is going to be a side-to-side parabola, something kind of like that maybe, unless we get a negative, of course. So this is what I'm trying to get. I want that y squared, y squared. You can see that it's going to end up that way in the end. So I'm moving it over to get my y's by themselves and my x's on the other side. Make sure to change your signs. And how do I get this into this? And what you need to do is this thing called complete the square. Complete the square. I think I spelled it right. So complete the square. How does that work? Again, I'm assuming you've done this, but I'm going to kind of like teach it from the basics here, okay? I have two boxes, a plus and a minus, so I'm canceling them technically, but I want to utilize this and yet have this kind of as a remainder left over. The process is very fast. You take the middle term here and you divide it by 2, and so then I get a 3. And then I take that number and I square it, so now I got a 9. And 9 should be going in both of those boxes right there. So basically, I'm going to say plus and minus 9. So does that change anything here? No, because I could technically just cancel them. I don't want to cancel them because I'm going to use this, but I could, and it will still technically work. So let me rewrite what we're going to want in particular. Notice that I'm kind of like leaving in a gap there because I want to stress that this is what we're talking here. This is what we're going to change. Well, this is a perfect square, and it should change into this guy. The term that it'll always change into here, in fact, like here, is always here. Notice that was a positive 3. So those are always going to be the same whenever you're doing this complete the square business. I still have this minus 9, so what if I plus 9 on both sides just to get it over there, you know? And so I got negative 2x, and now I end up with a 4, yes, a positive 4 over there. And so I still want this ending format here. I'm very close. Notice I got my square, but I need this parentheses action for my x. And so what I'm going to do is pull out the negative 2 for both of those. And so I think I'm left with this guy here. What's going on is that I pulled out a negative, so I change the sign, and 4 is 2 times 2. So if you redistribute, you should be able to get the same thing as originally. You can already see what your center vertex is. Notice x is equal to 2. That's a positive 2, inside opposites kind of stuff. And then my y should be a negative 3. So I can already start deciphering this stuff here. Center vertex. My x is at 2, and my y is at negative 3, okay? So keep that in mind, that you have to be in the correct order. This negative 2 is equal to 4p. So I want to solve for p, divide by the 4, and you can see that I get a negative 1/4, and that's my focus distance. So my focus is very simple here. Because it's a sideways parabola and it's negative, it's going to end up looking like this maybe. We'll do a real proper graph here in a minute, but my focus is going to be more negative. It's going to be more on the negative side of things. And because it's a sideways parabola, I'm going from the center to the focus in an x direction. This is my x values that are going to change. I don't know why I got 1/4. It should be 1/2. Sorry. Okay, that's better. I was looking at the wrong place. We're good. 1/2. Y'all were going to catch me on that, right? Always wait to the end. So 1/2. It's a 1/2 distance and 1/2 x distance. And so what I'm going to do is I'm going to say 2 minus the half, comma, negative 3. Okay? And then my directrix is going to be in the opposite direction. And so it's going to be something kind of like this here. That's an x equals because it's a vertical line. So I'm going to say 2 plus the 1/2. Okay? Notice that I have this minus plus kind of business here. They're always opposites of one another, and that's how you get this easily to work. So in reality, what should it be? Well, positive 2, negative 3. So there's my center vertex. I'm going a half distance for my focus, which is like right there. So this will be a pretty wide parabola. There's my focus. And then my directrix will be like right there. And there. Cool. Well, there's my graph. Not the best, but, well, it's better than nothing, I guess. Okay. Next question. 10, 5, 0, 1, 0. I have a parabola already created for me here. At negative 2, 1, I have a center vertex thing, and it's going through the x-axis at 2 and at 0. So this is basically what we have. There's a focus somewhere right here. I'm not exactly sure where it is, but I have this, and they say find the equation. So what I did on my paper is I did something more algebraic, I guess you can say, but rather what we should be doing is focusing on the conic stuff, and it's going to make it much faster. So notice that this point right here is 2 comma, oh, hold on, sorry, 1 comma negative 2. This is my center vertex stuff. And so this is a regular right side up parabola. So I'm going to go I'm going to go x minus 1 squared is equal to 4p times y plus 2. Now let's pause for a second. How did I just create this? So because it's a regular parabola, I know that basically I got y equals x squared, right? That's basically my equation. Of course, I got to alter it a little bit. Well, notice that my x is the one that's squared, okay? That's the key factor as to, well, which formula should I use? You're using that one right there now. And so notice also I have this negative 1 and a positive 2. Again, inside opposites. So I had a 1, so now it's a negative 1. I had a negative 2, now it's a positive 2. The formula is x minus h squared, blah, 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 because h, whatever that value is just put in there. So if you got a 1, you got a 1. But here we got minus a negative 2, and that's how the two negatives make a positive, blah, 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 blah. I don't think I have to go that far for Calculus 2, folks, but I just wanted to make sure that y'all are okay with it. Okay, so this is what we have so far. And I need to find what p is. And then after that, I can find the rest of the equation and all that kind of stuff here. Well, I don't know what my focus is. It's just kind of floating out there. But I do know that we're touching the x-axis at 0, 0. So I can actually just plug in 0, 0 and start solving for p. And so I got here a 1, 2 negatives make a positive. And here I've got a 2. So what? It's an 8. Divide it. And so I got a positive 1/8. That is correct. So I got p is equal to positive 1/8, so that's a 1/8 distance right there. My directrix would be right here, and again, a negative 1/8 distance there. So my formula should then be 4 times the positive 1/8, and then y plus 2. You do not, that's my equation, you do not need to simplify. You're done. That's it. We're good. If you want to simplify, that's fine, but there's no need to. My focus should be where my center was. Let me just start with my center so you can understand where I'm going with this. My center vertex stuff is at 1 comma negative 2. And so I'm going to take that same style for my focus here. Notice I'm just going to go up a little bit, so my y value is going to change. I'm going to add an 1/8, and then my directrix is again my horizontal line, so that's a y equals negative 2 minus the 1/8. I hope that you're seeing this pattern. See that pattern? And in fact, if you really want to zoom out, notice this pattern here. Yeah, you see that? And so then I just tack on a little extra there. That's what my focus is. That's what my goal is, to show you there's patterns here that we replicated again and again, and it makes it easy to do. And I try to stylize my words and stuff to make that work. Okay, let's do some more. So 10, 5, 0, 1, 4. Okay, so I've got 36x squared is equal to 49 minus 49y squared. Now, I want to know, what is the shape here? And you might first think hyperbola because there's a minus here, but hold on. If I move this to the other side, so they're on the same side, they're actually both positive. Therefore, this is an ellipse. Ellipse. I don't think I spelled it right. There you go, ellipse. Okay, so an ellipse, basically something kind of like this. Or it could technically be something like that. I don't know. So this is good. What we need to do, of course, is to get a 1 right here in order for this to make sense. So I'm going to divide both sides by the 49. And so my 36 over 49 cancels basically. I'm just going to skip a step or two. This is 7/6 squared in the bottom. And then I have my y squared divided by 1 squared is equal to 1. Now let's pause for a second here. The 49 and 49 cancel, make a 1. And I'm putting a little square there because what's 1 squared is 1. Well, notice here with these guys for a second, what if I were to put this into the denominator? What I technically would have is a 49 over 36 all over x squared. So this is kind of like what I'm using now. I'm taking this and kind of putting it in the bottom so that like it should be all in the denominator. Well, I want this value to be something blah, blah, blah squared. And so what I did is I took the square root of both of those, but I also squared them. And that's how I got the 7/6 squared. In a way, I want you to simplify this right quick and tell me, do I get the same thing? So square it, I got 49, I've got a 36. Well, you know, two things in the denominator and push it up to the top, and there's your 36. And yep, it looks exactly the same as the last one. So I didn't actually do anything wrong here. I did skip a couple steps, but again, this is from pre-cal, and I'm just trying to get through this here with you now. So I really like this format because it's telling me particular numbers. And what I call these is my major and minor. Okay, so this is my major, and this is what I call the minor. Now, a lot of folks say A and B. They'll say A and B, and to me that's confusing because A's and B's, B's and A's, how do you know which one is which? So major is telling me it's bigger. Is 7/6 bigger than 1? Yes, it is bigger. It's not bigger by much, but it is bigger. Notice that because it's bigger in the x, it's an x major. This is an x value, I guess you can say. And this is going to be a y minor. So x majors for ellipses look something kind of like this. Notice that my x distances are bigger than one another, or bigger than the y's. And so there's my graph right there. In fact, there's no shifting here. If they had some kind of pluses and minuses up there at the top, we would shift it, but they don't. This is my picture, this is my graph, we're done with that, pretty easy. But I can actually get it more specific. In fact, if I go 1, 1, 1, 1, that would make a circle, but I'm going 7/6, so it's a little bit more than 1, and that's how far I'm going to go out with my ellipse. And so again, this distance here is 7/6 distance. This height, though, is only a 1, like 6/6 versus 7/6. So there's my graph. Cool. Now I need to actually find all this stuff. So now they officially call it the center because the vertices are not at the center anymore. And then they have my foci, that is plural, that I need to solve and figure out. Well, it's centered at 0, 0 because we didn't shift anything. And so what I do when I go in WebAssign is I say, it's 0, 0, so I just start putting a 0, 0 all the way down. Now I'm leaving a little bit of gap because I want to show what else is going on, but I literally typed this into WebAssign because I already know that I want to have this style, but I'm just going to say plus or minus a little bit, okay? In fact, I think I did it a little bit wrong. I want to do it like this. Okay, that's probably a little better. Just give yourself a little bit of room. You can always go back and edit. But see that style, I'm going to basically just say plus and minus some kind of number that we need to be able to put in there, okay? So vertices, what are vertices? They're going to be on the major axis, okay? So to find the vertices, I'm going to say plus or minus my majors. And what are my major values? My major values are right there, the 7/6. And so notice also it's an x value. So I'm going to go take my x value, I'm going to say plus or minus the 7/6. Okay, so that's my vertices. That's my majors. In WebAssign, you probably have 5 boxes, not just the 3. And so you would have to put a negative 7/6 and then a positive 7/6, and then a negative this and that and a positive this and that. And so just be able to type it in correctly, understand the format that they're going to have. So for my foci, what I need to do is plus or minus C, and it's going to be in the same distance, the same axis as my majors, my vertices. And so my foci are somewhere around right here. There's my foci. They're somewhere on the inside. I don't know exactly where. I need to find that distance to be able to figure out what that plus and minus is going to be. And so there's a formula for that, and we're going to find it out. But eventually what I'm going to do is say plus or minus and some kind of number right here. Because again, it's going to be an x distance. We're going along the x-axis. So that value is C, and there's a formula for it. There's C squared is equal to major squared minus the minor squared. So that's my formula. Again, some people do A's and B's and stuff like that. I don't really know. I just do major minor because, well, I know what the majors and the minors are. It looks like that. So I can just plug it all in very quickly. I get my answer. You could square root both sides. My C is equal to the square root of 13 over 6. Again, I'm skipping steps here, but I mean, well, it's calculus too. So how many times can I make that excuse? So I put that in, plus or minus square root 13 over 6. I don't know what that number is, but it's some kind of number, and that's that distance here and here, plus or minus. And that's it. That's all we had to do. I really hope that you're seeing this style, this format here is always the same, and then I just simply say plus or minus something, plus or minus something, and it really makes it faster. Don't simplify. Why simplify? If you simplify, it actually doesn't make it look any better. It makes it look worse. 10.5.016. So we're going to be doing the same thing as last time, but much more complicated. This actually, I have it written in my notes here. It says classic, and you know that's a bad thing. So this is actually an ellipse. The reason why it's an ellipse is because we got both positives right here and here. And so what I want to do is actually I want to stylize it to be an ellipse style. To be able to do that, though, I need to move this over so I don't have a 0. It has some kind of number. And these guys here, eventually I'm going to complete the square with them. So I'm going to skip a couple steps, but I'm not really skipping steps here. I'm just showing, I guess, a quicker style like that. Okay, cool. So what I did is I took the 9s out to the front because this is going to be a problem. If I can't complete the square just kind of like that, but I can do it like this. Notice the plus and minus is going to stay on the inside here. And these guys, there was a 1 in there, so you don't really have to worry about that. You could just do the normal stuff. To complete the square, I'm going to take the negative 10 divided by 2 to make a negative 5. Then I'm going to take the negative 5 and square it to make a positive 25, and that is what I'm going to put here and there. 25, 25. This guy is super easy. 4 divided by 2 is going to be a 2. 2 squared is a 4, and so I'm going to put a 4 both here and there. Now, what I, as a student, always messed up with is I forgot to take the 9 and distribute it to every single term. I'll show you which I mean by that here in just a second. So that's going to be an important fact to do here. So this part there is actually to complete the square. Notice I'm going to have a negative 5. But that 9 is part of this part, and that's all this. But now I need to also make it part of this little piece here. The 9 is included with that 25. Very, very, very important. If you don't do that, it will be wrong. Please do that. That's the important side here. This side's super easy because this here is going to be my x plus 2. Oh, I wonder where I got my 2 from. Who knows? And then I have my -4 still equals a -193. Eventually, I'm going to take these here and move them over to this one side, so all my constants are on one side. And so then I have this on one side, and on the other side I actually get a 36 of all numbers. Divide by 36 on both sides, and so I end up with here a 4 in the bottom. Actually, hold on. Yeah. A 4, yes, which is going to be a 2. Correct. Yeah. 9 divided by 36 is going to be 1/4, so the 4 is in the bottom. But because I want to make that 4 a square of some kind, it's actually a 2 squared. On the other side of things, the 36 has no competition, so that's just going to be a 6 squared, now equal to 1. Again, I'm just basically taking this as a fraction, saying, what is that? That's 1/4, so it's 1/4. See that? Okay. Same thing here with 36 is just 6 times 6 is 36. I want those squares because you can see now my major minors. And this is the bigger one, so this is going to be my major. It's a Y major. This guy right here, he's my minor. We'll use him in a little bit. But it's a Y major ellipse, and so essentially it looks something kind of like that. It's bigger on the Y. Of course, it's been shifted some, so we'll be also moving it around in that regard as well. Actually, let's do that. Let's just do that now. 1, 2, 3, 4, 5. I'm going to go down to 1, 2. So there's my center. Well, that's my center, literally. 6 distance for the Y. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 distance. And then my X distance is only going to be a 2. So I was right here. 1, 2, 1, 2. And that should be my ellipse. There you go. Not perfect, but you're getting the idea, I hope. Okay, awesome. Now, let's actually answer the questions that they're wanting. So they have my center. They have my vertices. And then they have the foci. Okay, so my center, as you can see, is going to be 5, -2. And so what I do is 5, -2, 5, -2, all the way down. And then I need to start finding my major minor stuff. Well, major of 6, and so I'm going to say plus or minus 6 right here. Again, that's going to just be the major, plus or minus your major. Your foci is going to be plus or minus C, and C squared is equal to major squared minus the minor squared. Well, I have both of those. That would be my 6 squared minus the 2 squared. So 36 minus 4 is 32. You square root both sides, etc. C is equal to the square root of 32. So that's what I'm going to put here, plus or minus the square root of 32. Okay, awesome. And that's it. You're done with that problem. Moving on. So 10, 5, 0, 2, 1. I have y squared minus x squared is equal to 81. And they say, go ahead and find the shape and all of its stuff. Well, this is a hyperbola for sure. If you notice that we got a positive here and a negative there. So when you have them alternating, it's going to be a hyperbola. What does that shape look like? Something kind of like this. I'm not exactly sure what it's going to look like, but two separate, they're not parabolas, but it looks kind of like them if at a close distance. Okay, so let's actually do some math here. In order to find out what these are going to be, I need a 1 right here, so I'm going to divide by 81 on both sides. And 81 is technically 9 squared, and so I got a 9 squared, and 9 squared equals 1. And now I can find my majors and minors. This is actually going to be my major. I know they look the same, but it's a y major because this is technically a positive 9, versus here this is a negative 9. And so in a way I'm saying this is a positive distance major bigger than a negative 9, which is technically mathematically a smaller distance. So positive 9, negative 9, you would say chomp chomp the bigger one, you know? So technically this is less, and therefore it's minor. And so this is my minor. I got my y major, even if they are the same number. Okay. And that's going to be my picture because it's actually centered at 0, 0. So I go up 9 distance, so this is a 9, this is a negative 9, and there you go. Ta-da. So let's figure out what they're wanting answer-wise here. Should be pretty fast because we're basically done. They want the center. Well, there's no shifting, you can see, so 0, 0. Find the vertices. Again, that's just going to be plus or minus the major. So I'm always going to just put the same thing down. Foci, pretty easy here. Again, 0, 0, we'll just have our C. So for the vertices, I'm going to say, again, plus or minus the major distance. And major on the actual variable that we need. So it's a y variable, y-axis, so then I'm going to say plus or minus on the y value. My C formula has actually changed for the hyperbolas. It's major squared plus the minor squared. So this is a little different formula. The sign here is opposite of the sign between them. So if you had a plus sign, it would be an ellipse, and you put a minus sign right there. If you had a minus sign like here, then you got to put a plus sign right there. Okay, well, it's kind of funny because both of them are 9s, but, you know, that happens. It's whatever. And so what I want to do here is I find that's 81 plus 81, 162, square root it, you get 9 square root 2, basically. So plus or minus 9 square root 2. Okay, cool. Now, finally, for the asymptotes. Asymptotes. So every hyperbola actually has asymptotes, and let's talk about that for a second. Basically, they look like this. Oops, asymptotes are straight lines. And eventually it kind of rides up really close to those asymptotes. So you can see they're not quite parabolas. Hyperbolas have this kind of shape here. So we're trying to find out what those asymptotes are going to be, and I got to give you the formula because it's kind of complicated. Y is equal to plus or minus y distance divided by x distance times x minus h and then plus the k. All right. So what's going on here? This h and k are super easy. Those are going to be 0 in our particular case. But what is the y and x distances? Those are majors and minors. Majors and minors. Okay, kind of depends on what's going on. So in our particular case, we have a y major. Okay, so y major is a 9. Well, that's my y distance is a 9. So this guy right here is a 9. But what if I had an x major? Well, then the major would go down here. It's not like I'm saying it's always major divided by minor, because it's not always. It could also be minor over major. It kind of just depends on the problem, but it is always a y over an x. And so regardless, it might be major on the top, it might be a major on the bottom. It doesn't really matter as long as you're following the y over x. And this right here in particular, why is it y over x? It's because this is a slope. I'm basically saying it's a rise over a run. And so I've got to always keep the format of a y value over an x value, regardless of what is major minors, okay? But I'm using the major minor values, like the numbers, to be able to get that stuff. So x in the bottom here, x is a minor in this case, and it turns out to be a 9. And so what I actually get is kind of weird here. I get 9 over 9, because essentially what you're doing here is you're just looking at your values here and here. So you're dividing them. Now it might be this one on top and that one on the bottom, or that one on top and that one on the bottom. Regardless, 9 over 9 is going to make a 1, and so I got a 1. Oops. So I got basically plus or minus 1 times, well, x. And if you want to actually write that out, it's plus or minus x. This is right here, your asymptotes for this particular problem. And so they look like 45-degree lines. And your hyperbola will follow them as it continues towards infinity. Okay. Another one. Actually, we're getting close to the end. This is not the last one, but we're getting close. So 10, 5, 0, 3, 5. I've got a parabola, so it tells me it's a parabola. It tells me that there's a focus at negative 10, 0. And it tells me that there is a directrix at x equals positive 8. It's a positive 8. Okay, so they're telling me all this stuff. So notice that it's a parabola and it gives us one focus. So I know for sure that it's definitely a parabola because a parabola only has one focus. Everything else has two. The directrix is giving us so much extra information. And this right here, I have is a vertical line at 8. 1, 2, 3, 5, 6, 7, 8. Okay, my focus is at negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my focus. So my center vertex is somewhere in the middle. And in fact, because it's a parabola, it's exactly in the middle. And so I have basically an 18 distance. Half of that is going to be 9. So a 9 distance from either one of these is actually going to be right here at negative 1. So that's my center vertex, whatever you want to call it, okay? And because the focus is always on the inside, it looks something kind of like this. There's your parabola. Okay, so we graphed it. Yay! But we actually have to go and find out the values. Actually, no. What they're wanting here is the equation. So it's a sideways parabola, and so I'm going to have a y squared. So y minus k squared is equal to 4 times p times x minus h. That's my format. Well, my center here is at negative 1, 0. If you could tell, it's just 0 is my y value. And so I've got y minus 0 squared. For p, I'll fill that in here in a second. And then I got negative 1 for my h. 2 negatives will make a positive here in a second, so that's pretty easy. So what is my p distance? Well, the distance from here to here is 9. And notice in particular is a negative 9. Aren't I going in a negative direction, right? And so my p is equal to a negative 9. I guess I can do plus 1 now. And that's actually it. You don't have to write the 0. This is technically a negative 36. I'd like to keep it just like that. The end. That was it. I have one last question. Here we go. So 10, 5, 0, 4, 7. I have a hyperbola, so it tells me it's a hyperbola. Gosh, my handwriting's really bad today. Hyperbola. They give me some information. It says that the vertices are located at negative 3, negative 4. Look for some patterns, and then negative 3, comma 6. You see something in common already? Watch this. So my foci are going to be negative 3, negative 8, and negative 3, comma 10. What do they all have in common? A negative 3. So my x value is constantly a negative 3. And so whatever's going on, I have some stuff like up here. I got some stuff right there. We got some, hyperbola stuff. There's your foci. Regardless, it looks like this, and so this is a y major. And so in particular, what I'm going to have is a y minus k all squared divided by major squared, and then a minus sign x minus h squared all over the minor squared equals 1. This is my format. That's my equation I'm going to look for in the end. I just now need to fill in the gaps. And I should be able to find the center pretty easily. Basically, it's going to be in the middle of all that stuff. And you can take the middle of either one. I'm going to just take the middle here. So negative 3, obviously. But what's in the middle between these guys? Well, it's like a number line. Think of it like this. I got negative 4 over here and a positive 6. And I want to know, where's the middle between those guys? Well, the total distance here is a 10 distance. So I cut it in half and make a 5 distance from either side. And if you go a 5 distance from either side, it's actually going to be a positive 1. So positive 1 is right in the middle. So my center is going to be negative 3. All the x's are negative 3 today. And then a positive 1 for my y value. That already gives me a whole lot of information. But let's go one step further. If this was my center and these are my vertices, then what was that focus distance? I'm sorry, not focus, the major distance that we had to travel. What was my major? It was 5. So I'm going to say plus or minus 5. So I'm going to say my y major is a 5. And so here we go. I can already start filling this in. Y minus the 1, again, there's a y value here, squared divided by 5 squared, that's my major, minus sign, because the hyperbola, y plus 3 squared, again, x value. And then I have my minor squared, I don't know what that is yet, equals 1. So I just need to figure out what this guy is. Well, there's that formula for c, major squared plus the minor squared. And I don't know what some of these are, but I do know some of them. What is c, though? Can I find c? Look at these guys. If I started at positive 1, and I'm going over to negative 8 and over to positive 10, then what is the distance to the foci? What's that focus distance? And so you can actually see it's going to be a 9 distance, right? It's a 9 distance on either side. I'm going either minus 9 or plus 9. And so my C is a 9, my major is a 5, and I don't know what my minor is, but I can now solve for it. Subtract this to the other side and square root it, and what you find is that your minor is equal to the square root of 56. And so my final, and I'm just going to plug that in right there, final answer, y minus 1 all squared divided by the 5 squared minus x plus the 3 squared divided by the square root of 56 squared, it's minor squared, is equal to 1. And again, you can simplify it, of course, but I don't. Just personally, I like it like that. And that's all I got. So thank you very much and have a great day.